Hello everyone. Today we're going to learn about Pythagoras' theorem. Now, Pythagoras' theorem is all about making squares. Here we have a right angle triangle. Now, Pythagoras' theorem only works for right angled triangles. Here I have a right angled triangle. Now, each of these lengths has to be a very specific length, or otherwise it wouldn't be a right angled triangle. If this length here was only half the size, it wouldn't make it all the way across. So each of our lengths of our triangle have to be a very specific size. Right-angled triangles have a property that says if we turn this bottom short side into a square, and we turn this other short side into a square, the area of these two squares is going to be the area of this big square. So let's have a look at this. If I have a triangle, now this is a very special triangle, a 3, 4, 5 triangle. Now, if I turn this side here and I make it into a square, grab another color. So if I turn this 4 and I turn it into a square, now this square has a side length of 4 and another side length of 4. So this square is going to have an area of 16. Now we're going to turn the other short side into a square. So this had a size of 3. So we're going to turn this into a square of size 3 and 3. Now this square has an area of 3 times 3, which is 9. Now we have our big side. Now our big side has a side length of 5. So we're going to turn that into a really big square with a side length here of 5 and a side length here of 5. The area of this square would be 5 times 5, which is 25. So this has an area of 25. You can see here, I have an area of 9 and an area of 16. 9 plus 16 is equal to 25. So these two squares add up to become this square. So we have a mathematical formula to write this relationship out and to help us calculate this relationship. This relationship is a squared plus b squared is equal to c squared, where a and b are the small sides and c is the big side. Now what we did here was we turned 4 into a square. So we did 4 times 4. And in mathematics, we represent that with a little square. So this would be a times a, this would be b times b, and this would be c times c. It's like over here we did a times a, 4 times 4 is 16. Our b is squared is b times b, 3 times 3 is 9. And this equals c squared. This is what Pythagoras' theorem is, and we can use two unknown sides to work out an unknown side. So if we know two sides, we can always work out the third. Let's go do a couple of examples. Test this theorem, and so you know what to do when you come across a question with a right angle triangle. Here I have two examples. Over this side, which sides of my triangle do I have? I have my two short sides, and we are going to work out the long side, the big side. So what we have is we need to use a plus b, but they are squared. So remember, we turn everything into squares, is equal to c squared. So here I have an 8, and here I have a 6. Now you'll notice that we are just plussing two things together. So if we did 5 plus 3, we get 8. But if I do 3 plus 5, I also get 8. So it doesn't matter which one you say is A and which one you say is B. It will always work out, as long as it's not the long side. The long side is always C. So here we have A. Now I'm going to say that my 6 is my A. So we are going to do 6 squared plus 8 squared, and that's going to give me my C squared. So 6 times 6 is 36. 8 times 8 is 64. Now, if we were to show this with a picture, we have our 8, we turn it into a square, we have 8 times 8, which is 64. And here I have a 6. We're going to turn that into a square. And we are going to end up with 6 times 6, which is 36. And this equals our square, our big square over here, our square of C. The 36 plus 64 is 100. So our C squared is 100. So if I was to draw a square here, this would be the size 100. When we are looking at this triangle, we don't want the square, we want the long side. So what we're going to do is we're going to take what's called the square root. It's the root of our squares. It says, what are my sides of my square if the area is 100? So what we're going to do is we're going to take the square root of 100, and we are going to take the square root of c squared. This square root turns it back into a line. So if we have a line and we turn it into a square and we turn it back into a line again, these things are just going to cancel out. What two numbers times together give me 100 that are the same? 10 times 10. So the answer would be 10. So 10 is equal to c. So this length here is 10. Now we use the fact that this short side, make it into a square, and then this other short side, we make it into a square, add together to give me that side there. Now with this other example, we don't have the two short sides, we have the long side and the short side. Algebraically, we can rearrange our formula, so we end up with a squared plus b squared is equal to c squared. So if we're trying to find what our a is, then we need to move our b over to the other side. In order to move the b to the other side, we must take away b from both sides. So we end up with a squared is equal to c squared minus b squared. Now if you think about it, that also makes sense, because if this plus this give me this, then if I think backwards, then this minus this will give me this. We're going to do c squared minus a squared or b squared, whichever one you've decided to call this side. So we have a squared equal to 15 squared minus 12 squared. Now, if you put this into a calculator, 12 squared is 144, and 15 squared is 225. We're going to end up with 225 minus 144. And that's going to give us the square of size A, the short square. So if we chuck this into a calculator, we get 81. So this square is equal to 81. But we're not after the square, we're after the line. So we have to take the square root of both sides. So we're going to take the square root of A, and we're going to take this of A squared, and we're going to take the square root of 81. So the squared and the square root cancel, so we end up with A is equal to what two numbers that are the same times together to give me 81? Well, 9 times 9. So this ends up being 9. So this short side ends up being 9. This is the process for Pythagoras' theorem. If we have the two short sides, we add the squares together, and then we square root it. If we have a long side and a short side, and we're trying to find the other short side, then we have to take away the small square from the big square, get what's left over.